Welcome to this class. In this session, we are going to give more examples on finding partial derivatives of function of several variables. So examples. So find all the first partial derivatives of the function v of xy equals to sine of x y. Actually, this is an appetizer. Solution. So partial v, partial x. So we differentiate this function by chain rule, assuming that x is constant, because now partial x. So if you fix this one to be u, so u will be xy. So du dx of partial u partial x just be given by y. So partial v partial x will be given by partial v partial u times partial u partial x. So partial u partial x is y. And then when you differentiate sine of u, you get cosine of u. So the cosine of, and u is x, y. And then partial v partial y be given by, so same thing, fix this one to be u, partial y now will be x. And then when you differentiate sine function, you get cos function. So this will be x cos of x, y. And then number two, show that the function f of x, y given by ln of x squared plus y squared satisfies this Laplace equation. That is partial squared f partial x squared plus partial squared f partial y squared is 0. So this is a partial derivative into a partial Laplace equation in 2 dimensions. To solve this, solution. So we have partial f, partial u, partial x. Now, when you differentiate an ln function, you get, so if you fix all this part to be u, so that we have f equals to ln of u. So partial f, partial u will be given by 1 over u. And then partial u, partial x, we are using chain rule, will be given by 2x. So that one tells us that partial f partial x, which is partial u, partial f, partial x, partial u times partial u, partial x. This one is 2x. And then partial f partial u is 1 over u, but this is our u. So we have x squared plus y squared. And then partial f partial y similarly will be given by partial f partial u times partial u partial y. Partial f partial u is 1 over u, and then partial u partial y. If I get this function with respect to y, this is a constant, so 0, and then 2y. So we have 2y over x squared plus y squared. Now we need to get the second partial derivatives. I remember partial squared f partial x squared is the same as partial x of partial f partial x. So we let this one to be u, this one to be u, and then this one to be v. So we are going to use quotient rule, which is given by u prime v minus v prime u over v squared. So when you differentiate this function with respect to x, you get 2. You have 2 times v, which is x squared plus y squared, minus, when you differentiate this denominator partially with respect to x, so y is taken to be constant, so 0, so it will be 2x. So 2x into u, which is 2x, divided by the square of this. So we have x squared plus y squared, and then square. So when you simplify, you'll have 2x squared plus 2y squared minus 4x squared, everything divided by x squared plus y squared squared. Now this tells you we'll have 2y squared minus, so 2x squared minus 4x squared is minus 2x squared over x squared plus y squared, and then square. Now, similarly, let's get partial squared f partial y squared. This will give us partial y into partial f partial y. So similarly, we use quotient rule to evaluate this derivative. So this is u, and then this one is v. So u prime, this with respect to y, you get 2. So we'll have 2 into x squared plus y squared minus, when you differentiate this one with respect to y, we get 2y. So we'll have 2y, and then times u function is 2y. So 2y divided by x squared plus y squared square, for this is a v squared. Now when you simplify, you'll get 2x squared plus 2y squared minus 4y squared divided by x squared plus y squared square, which on simplification will give us 2x squared, 2y squared minus 4y squared is minus 2y squared divided by x squared plus y squared square. So therefore, remember this was the partial squared f partial x squared. So adding these two, this implies that partial squared f partial x squared plus partial squared f partial y squared is given by Here we have 2y squared minus 2x squared divided by x squared plus y squared plus 2x squared minus 2y squared divided by x squared plus y squared square. Now you see these two fractions have the same denominator. So this will be, put them under one LCM, x squared plus y squared squared. So this would just be 2y squared minus 2x squared plus 2x squared minus 2y squared. And with this new expression, it should be clear that 2y squared minus 2y squared is 0. 2x squared minus 2x squared is 0. So therefore, the numerator is just 0. 0 over the denominator, which is x squared plus y squared squared. And 0 over this square is just 0. So therefore, the function satisfies the Laplace equation of 2 dimension. And lastly, this, given that u of xy is given by x squared sine xy, find partial u partial x and partial u partial y. So in this case, so this part 1, this part 2. So partial u solution, partial x. R is a product x squared and sine xy. So you use product rule. So taking this one to be u, this one to be v, this function. So this is be u prime v plus v prime u. This is a product. So this one with respect to x will be 2x, then multiplied by sine of x y, plus, when you differentiate this one, use chain rule, differentiate sine function, you get cos function. And then when you differentiate this part partially with respect to y, so you just get, with respect to x, you get y. So to be now y cos of xy times x squared. So we'll have y x squared cosine of x y. So that is the answer to that first part. And then partial u partial y, this one doesn't depend on y, so just this is the main part. So you use chain rule. When you differentiate this part with respect to y, you get x, and so that x you multiply by this one will be x power 3, and then cos of x y. So that will be given by x cubed cosine of x y. And then lastly, find all the second partial derivatives of the function f of xy given by 3xy cubed minus 2xy and then plus sine of x. So to get the second partial derivatives, you have to start with first partial derivatives. So solution, you start with partial f, partial x which means you assume the only variable is x. Anything that is not x is taken to be a constant. So this first part will give us 3y cubed. This part will give us minus 2y. When you differentiate sign, we get cos. And then partial f partial y. This part will give us 3 by 3 is 9, x, y power 2. This one will give us minus 2x. This one is 0 because there's no y here. And then partial squared f partial x squared is given by partial x of partial f partial x. So similarly, you differentiate this function with respect to x, so which will be just given minus sine of x. Both this and this one do not have x, so their derivatives are 0. And partial squared f partial y squared is partial y partial f partial y, which is given by differentiating this one with respect to y, we just get 18xy. And then mixed partial derivatives. So we have partial squared f partial x partial y means partial x of partial f partial y, which is the same thing as now. When you differentiate this one with respect to x, you get 9y squared minus 2. And then if we reverse the order, we say partial squared f partial y partial x, the same as partial y into partial f partial x. So this one here, you differentiate with respect to y now. So this will give us 9y squared. This one will give us minus 2, but this other part is 0 because there's no y here. And from this example, you see that these mixed partial derivatives are the same. So partial squared f partial x partial y, which is 9y squared minus 2, has the same value as partial squared f partial y partial x. This always happens whenever the partial derivatives of the function are continuous functions. Then the mixed partial derivative, whichever order you start with, you get the same answer, provided that the partial derivative functions are continuous. And then just a summary on the second partial derivatives. When we write partial squared on summary of writing partial derivatives, so we write partial f partial x can as well be written as f, then you write sub x. And partial f partial y can also be written as f, and then you write sub y. Now for the second partial derivative, so partial squared f partial x squared means you apply partial x to partial f partial x, and this can be written as f x x. So which is the same thing as saying fx, and then you also partially differentiate with respect to x. And then partial squared f partial y squared is partial y of partial f partial y, which is the same as partial y, which is the same as saying fy and then y. And for mixed partial derivatives, so partial squared f, partial x, partial y means partial x, partial f, partial y, which is the same thing as saying partial x. And we say this one is the same as writing f sub y, which is the same thing as writing f sub y, and then x, partial x, and this is the same thing as writing f y x. And lastly, partial squared f, partial y, partial x means partial y of partial f, partial x, which is partial y, partial f, partial x is f sub x. So this is the same as f sub x. Then you partially differentiate with respect to y, which can be written as f sub x y. So this is how we rewrite second order partial derivatives or first order partial derivatives in terms of just f and then some subscripts. So in a similar manner, you can define the third partial derivatives, fourth partial derivatives, etc. So thank you.